Hello and welcome to Talking Defense, Rafael's Defense Magazine. Every program will be dedicated to a different subject with all relevant experts, data and aspects here in the studio and from around the world. And today, a look into the future. And today with me in the studio are Dr. Irit Idan, EVP Research and Development, Rafael Advanced Defense Systems, Dr. Nitzan Link, CDO of Technology Center, and Dr. Golda Kishilev, MEMS Technologies Group Leader. Thank you so much for joining me today. So Irit, we'll start with you. What exactly innovation and what are we looking heading to the future?
Well, usually when thinking about innovation, the words bring up images of scientists in white coats or entrepreneurs with revolutionaries idea. I believe that innovation is a much wider word in that respect. In my opinion, is responding to a challenge in a creative way. It can be generating new ideas, conducting R&D, designing new products, and even improving processes. Now, through the year, Rafael positioned itself as a highly innovative company. Through the years, Rafael positioned itself as a highly innovative company. From the early age, we focus on high-end technologies, mainly for missile systems, with high-end technology in electro-optic seeker, image processors, and RF communication. In the last decade, we added to our portfolio data analysis, artificial intelligence, and cyber. Now, all these high-end technology, when you master them, you are able to do the conduct and think about the innovation for the next decade.
But Irit, the task that is expected from you by your managers is not to look for 2022, but to look to 2030, 40, 50, 60, which is way ahead. The world has changed dramatically every decade because of the new technologies you've mentioned, cyber, et cetera, et cetera. How can you anticipate what's going to be here in 30 years' time?
That's the beauty about it. We are the fourth industrial revolution. There are so many technology around us. This is the time of the technology. We're talking about additive manufacturing, synthetic biology, artificial intelligence, quantum. The beauty about Rafael, that Rafael is dealing with all of these technologies. What we are doing in the R&D when trying to build roadmap for those technologies for the future, we look at the benefits and what this technology can bring to our own products in the future, what our customers dream about that we can fulfill. Because of that, last year, the Forbes magazine chose two of Rafael's systems, Iron Dome and Trophy, to be in a short list of the 12 most important weapon systems of the decade, which is a huge honor for Rafael. And this is coming all because of this technology that we developed through 20 and 30 years
So
ago.
I'll give you a couple of minutes until I finish the roundup here to think of what the battlefield will look in a few centuries ahead. But Nitzan, I want to ask you, speaking of materials, that has changed dramatically as well. I mean, the airplanes, the missiles didn't look the same 20, 30, 40 years ago.
No, of course not. We are in a constant search for the next level of the materials properties. We are looking about the advanced materials, the enhanced properties of the materials. Did you know, for example, that you can make this ceramic transparent? We can do that, and we can use it for windows that are bulletproof instead of very large and heavy glass windows. So this is a simple example for how we can change the properties of a material to give us an added value for our products.
But you went to kind of a civil example. I'll take you back to your world, the defense world.
Yeah.
Take an Iron Dome that Rita's mentioned. The materials are so advanced in all aspects. How do you deal with that? And again, how do you foresee the future?
Well, the material research always looks ahead because it takes a long time to develop a new material. You cannot do it in a year or two or in a process of a recent project. You have to think about the future project. So you always have to do your research, you always have to do your simulations, you always have to improve your infrastructure, you have to invest every day in order to gain the advances of the future material.
So Golda, heading on to you, and you deal with something that we all see on a daily basis, which is minimizing things. When we spoke before, I gave you the example of the telephone I used 20 years ago or 10 years ago to the one I'm using now, but it works, it applies to all worlds.
You're right. You talked beforehand about the future battlefield. So what we want to see in the future battlefield is more and more unmanned and autonomic systems. Systems that can gather intelligence, that can execute operations and without endangering our troops. So these systems, in most cases, have to be very, very tiny and be disguised. And this is our goal, to make them as small as possible, small in size, small in weight, small in power, and to give them the sensors that will replace the human senses. For example, the vision, the hearing, the touch, even the smell, or the ability to navigate in the field, the ability to interact with other systems, night vision, and process the data, and even make decisions. So how do we take all of these capabilities and combine them in a very, very tiny system? This is our goal, this is our aim, to take our sensors and make them as small as possible and as smart as possible.
So give me an example for...
Let's take, for example, an impact switch. This is a device that is used to sense an impact. When a missile hits the target, we need to know that because we want to trigger the warhead. So sensing this occasion, we need an impact switch. You can see here the size of this switch. It starts from a silicon wafer. Here is an example of a silicon wafer that has more than 2,000 of identical impact switches. When we cut the wafer at the end of the process, we get this kind of a die, and then we have to package it to make it, to enable it to be integrated in the system. And this is the size of a packaged device.
And just to compare, what was the size of the same device 20 years ago?
Well, it was much larger.
Quite big and quite heavy.
It was in a millimeter range, yes. And if you think that this is small, so our R&D efforts for the future aim towards even smaller devices, and are about to use quantum phenomena to give it the cutting-edge performance.
Is there an end to that?
There is an end to that. Because you can only make it as small as you're always limited with the atom size. But in the military industry, you use the micro-electromechanical systems. So we're talking about microns, and not going to the angstroms and nanometers.
So I head on to you, Irit. You're managing all these very smart people, including Nitzan and Golda and many others. What do you expect from them? What's the vision? Because you invent the future. You don't expect others to invent it and then implement it, but you want to be first because it's Israel, because we have to defend ourselves, because no one will be here for us, and because you're a scientist and you always want to be first. What do you expect from your people?
Well, first of all, it's not me. It's a collaborative work. There are over 4,000 engineers and scientists in Rafael that do this R&D project. What we expect from them to be number one or number two in the world. That's the beauty about it. If it's something that we can bring for the commercial sector, we'll bring it. We just have to find out what is the added value that we have to add to study, to investigate, to do the R&D out in order for our system to be better.
But you know, you say number one or two in the world, and I think you're rivaling huge conglomerates from the US, from Russia, from China, from Europe, here in Israel as well, and still heading. It's quite a phenomenon.
No, because our people are the best. And we are looking always for the best scientists and the best engineers, like Golda and Nitzan, to bring us the frontiers of the R&D in the world, and to find a way to implement them into our system. What Golda showed here, the impact switch over there, is one symbol. for that technology.
So, before we end, I'll take you back to what I asked in the beginning. What lies for us in the future, 30 years ahead of us? Give me an example. I'd invest in something.
Well, the only thing I can tell you that is that we live in an exciting time. This is the time of the technology. And if I'm looking at the technology for the future, I'm talking about autonomous system and hypersonic, artificial intelligence and propulsion, computer vision, and so many things. So we have to invest in all of those areas, but we have to remember one thing in our mind. All what I expect from all my engineers to bring this ingenuity of those areas, but to still enjoy it. Bring those technology, enjoy investigating them, and bring to Rafael product the innovation that we need for the next 20 years.
Fascinating. Irit Idan, Nitzan Link, Golda Kishilo, thank you so much for joining me today. And that's all from us for today. We'll be back shortly with another edition of Talking Defense. Until then, stay safe and stay tuned. Bye-bye.